Comparison test for series. A comparison test lets us know whether a series compared to another series would be convergent or divergent. So let us assume xn and yn to be two sequences such that xn is always less than or equal to yn, and these are sequences of positive terms. Okay, so these are two sequences which are sequences of positive terms such that xn is less than or equal to yn for all n. So you understand what I'm trying to say here is that x1 is less than y1, x2 is less than y2, and so on and so forth. Okay, so this relationship holds. Now, and let Sn be the series associated to Xn and Un be the series associated to Yn, okay, respectively. Now, so Sn will be the nth term of the series, nth term, that will be, because it's associated with Xn, so it will be x1 plus x2 and so on and so forth till Xn. Un will be nth term of this series, y1 plus y2 plus so on and so forth till yn. Then we observe that if un converges, then Sn will converge. Now you understand your xi's are less than or equal to yi's, right? For all I greater than or equal to 1. Okay, so each of these are greater than these. So in case this converges, then we can say that this converges. In case the smaller one, Sn is the smaller one diverges, then you can conclude that the bigger one will diverge. Let's try to prove it. Okay, let's try to prove it formally. Okay. Now, un, let's try to prove the first one. So, let us assume that un converges. So, what do we have to prove? That Sn also converges. Okay. Now, un converges. So, that means that since un converges, that means that we have that un is bounded. It's bounded. Un is bounded because it's convergent, so it implies it's bounded. But the inequality that we have, xn is greater than or equal to 0 and it's less than or equal to yn for all n greater than or equal to 1, gives that, it will give us that x1 plus x2 plus x3 plus so on and so forth till xn will be less than or equal to y1 plus y2 plus so on and so forth plus yn. Okay, so which means that 0 is less than or equal to Sn, which is less than or equal to un, right? The nth term of the series for all n greater than or equal to 1. Now, this is bounded. That means that Sn will also be bounded. Un is bounded. Okay, so that means you will have an upper bound for this also. Okay, 0 is the lower bound in any case. So that means that Sn is also bounded. Okay, it's also bounded. So that means that it's generating sequence. It's generating sequence. Xn's generated sequence is Sn is a series of positive terms or non-negative for that matter, right? Negative, because it's generated by xn. Okay, because of that would imply that Sn is also convergent. So Sn is a basically series of positive terms or non-negative terms which is bounded. So that means it will be convergent. And similarly, you can also have that the B part. Okay, what would happen if un converges? If un converges, then by the A part, by the previous part, we know that Sn converges. Okay? So just the contrapositive of this statement, un converges implies Sn converges. So that means when Sn does not converge, okay, so Sn is this equivalent to saying that Sn diverges would imply that un diverges for all n greater than or equal to 1. Okay, so that means when Sn diverges, un will diverge.